All right, we're given a system of equations. 2x minus 5y equals 15, 3x minus 6y equals 36, and we're asked to find the solution, the ordered pair xy, using matrices, using the inverse matrix. Now, when you're asked this on an exam, you can't use a different method. You must use this method. So let's go through these steps. We have the steps in our notes. Step 1. First thing is to write matrix equation. So this is a matrix equation that represents the system of equations that we are given. First, we have capital A, that's called our coefficient matrix, times capital X, that's called our variable matrix, equals capital C, that's called our constant matrix. That's a constant, just a number that doesn't have a variable in it. So we're going to write we lined up all the X's, all the Y's, the equal sign, and the numbers, the constant numbers, in the given system of equations. They're already lined up. So we can just write down the coefficients of X, 2 down below 3, and then negative 5 for the coefficients of Y down below negative 6. That is our coefficient matrix. It represents, the first column represents the X coefficients, the second column represents the Y coefficients. Times, okay, now for capital X, our variables are X and Y. X down below Y. Equals, and now the constant matrix, C, represents the numbers on the right side of the equal sign that have no variables. So that's 15 down below 36. There you go. A times X equals C. Step 2. We need to find the inverse matrix before we can continue. A inverse. Okay, so we have a formula for A inverse, the inverse of this matrix, the coefficient matrix. We're going to use that formula. Use formula. That'll make it pretty quick. So A inverse will be equal to 1 over cross product minus cross product. That will give us negative 12, 2 times negative 6, minus 3 times negative 5 is negative 15, times, okay, let's do the switcheroo on this matrix. Switch the diagonals, negative 6 upstairs, 2 downstairs, and just change the sign in front of the other entries. This negative 5 becomes a positive 5. Okay, let's simplify. And we get 1/3 times negative 6 down below negative 3, 5 down below 2. That's our inverse. Let me put a cloud around that. That's kind of important. That's our inverse matrix, A inverse. You notice I left 1/3 on the outside. It's going to be actually nicer to have the 1/3 on the outside, because if I distributed among all the entries inside of the matrix, I'd have fractions in some cases, and I don't want to work with fractions, so I'll leave it outside for now. Okay, step 3 comes from the fact that if we start with the matrix equation that we had up here, A times X equals C, and we wanted to isolate X, we would accomplish that by multiplying on the left side A inverse times A times X. You see how I multiplied A inverse on the left equals A inverse times C. So I have to be really careful about which side I multiply on. I'm multiplying on the left side for both of this original expression, for both the left side of the equal sign and the right side. Now let's put this together. A inverse times A is the identity, right? So we'll put the funny looking 1 times, bring down the X, bring down the equal sign, bring down A inverse times C. This is where that step 3 comes from. Well, the identity times X changes nothing, so it's just X. X equals A inverse times C. And when you do this problem, you don't have to go through these steps I'm doing here for step 3. Just use what I've written in the cloud. The result in the cloud is that I can find the variable matrix by just multiplying A inverse times C. And I found A inverse, and I know what C is. C was right here. Here's A inverse. We're ready to roll. Okay, so the variable matrix X is going to be equal to A inverse times C. That means little x, little y, that's our variable matrix, is equal to, okay, so this is going to be 1/3 times, I'm writing A inverse now, negative 6 down below negative 3, 5 down below 2, times the C matrix, which was 15 down below 36. Okay, now, we're multiplying, and we're allowed to move a scalar, which is a number, just a number that has nothing, it's a simple one-by-one matrix. We're able to move those around. So I'm going to move it inside this position, and we'll have that this is equal to -6 down below -3, 5 down below 2, times 1/3, that's just a number, times 15 down below 36. Now, I can see that if I distribute 1/3 inside of here, I'm going to actually get whole numbers. So let's go ahead and do that distribution. -6 down below -3, 5 down below 2, times, all right, 1/3 times 15 is 5. 1/3 times 36 is 12. Nice whole numbers. Okay, let's start another video to finish this off because this is getting too crowded.